Hello everybody, today I'm going to illustrate how to take a derivative from these two equations. To solve this kind of equation, we should know some kind of tips, ways how to solve these two equations. To know how to work with them, we should know two-sided product means we should take a derivative from two sides. For example, how we take a derivative from these two equations. Firstly, we should know some tips, of course, because here is given. Look, when you look, here is given arcsinx. From arcsinx, immediately it will be like impossible to take a derivative. But when you change the shape, it will be possible to take a derivative. What about from here? Of course, from here it will be possible because here is given exponential functions. But when you take it immediately, derivative, it will be again impossible. But it can be possible. It can be like straightforward how to take a derivative when you use some tips. Here, okay, y given y equals to arcsinus x. Okay, arcsinus x is given, but we don't have any kind of formula how to take a derivative from arcsinus x. But it can be possible. It can be possible when you use this two-sided product or two sides from. We should take a derivative from two sides. So here we should just label. Or we may increase second degree both sides, or we may write the sinus. I mean both sides. Here we should use that one. Like we can write as sinus y equals to sinus in the bracket arc sinus x. So from formulas, we know that sinus arcsinus x equals to x, because instead of x we will be given alpha. So these expressions can be cancelled. After that, we can see here we'll be left sinus y equals to x. So here from both sides we should take a derivative, because right now it will be a bit straightforward to take a derivative. So here let's copy here sinus y equals to x. Then when you take a derivative from both sides, this one will be from sinus, it will be cosinus y, and of course we should forget that we are taking a derivative from y, not x. So this means we should again write the value of the y, like y taking a derivative. Here it should be written, because it will be complicated derivatives. So this means we should take a derivative from each expression. It's called complicated derivatives. So here, then after that it will be from x, when you take a derivative it will be 1. Of course, we shall find the derivative of arcsinus x, but here we're just simplifying it. Here also we shall find the value of the y, and it will be 1 divided by cosinus y. So here derivative of y just can be connected with again y, but it's not connected with x. But we should connect it with x, not y. So here we should just put the value of the y here. After that it will be 1 divided by cosinus arcsinus x. So here we should use some methods, some formulas to write this one only x instead of other expressions. We should put some kind of formulas. But we know that from trigonometric identities that sinus x equals to plus and minus root 1 minus cosine second degree x. So instead of sinus, we put this one, or instead of cosinus x, we put plus and minus in root 1 minus sin second degree x. So when you put the value of the arcsinus here, like instead of arcsinus x, we should put the x. Then after that we shall find the value of the cosinus. But again we should write this expression as arc cosinus arcsinus. This means the value of when you take a derivative from y, it will be 1 divided 1 minus x second degree in the roots. So the derivative of this expression will be 1 divided by in the roots 1 minus x second degree. So when you look to this expression, how we take a derivative from this expression? Again, another question. Here, we should label, or we should use some message to know to work this question. Here, we should write both sides as ln, like ln e in the exponent y second degree ln x. So I'm just using this method because we know that from logarithms ln e equals to 1 from the formulas. So we can use this formula in this question. And here it will be like y second degree will be exponent of e. After that, we can write as multiplication to this expression. Then it will be y second degree and ln e equals to 1. It will not be necessary to write 1 and equals to ln x. It's just simplified a little bit, but here it was not simplified a little bit. Here, again, we may just go on working. We should just take a derivative from both sides. We shouldn't forget that. So when you take a derivative from both sides, it should be from y second degree, it should be 2y. And again, we shouldn't forget that it's just complicated derivatives. This means we should again take a derivative from y. Okay, then it will be y derivatives equals to, from ln x it will be 1 divided by x, which will be. So again, we shall find the value of the y here. It will be 1 divided by 2x and y. As you can see, the value of the y can be connected with again y, but the answer should be only with x terms. There shouldn't be any the value of the y. Again, we shall find the value of the y from here or from here. Now it will be a bit straightforward when you find the value of the y here. So the value of the y here, it will be in the roots ln x. After that, when you put the value of the here, the derivative of this expression will be 1 divided 2x in the roots ln x. So this is enough. Thanks for watching. Take care.